Okay, guys, so today we're going to talk about the average value of a function and the mean value theorem for integrals. So basically, we kind of know like the old-fashioned way to find the average of a discrete number of things. So, if we have, um, you know, oops, let me switch my marker. We have some, let's say we wanted to find the average of discrete, meaning a countable number, discrete number of things. We would just say that we could do x sub 1 plus x sub 2 plus x sub 3 plus so on and so on and so on, all the way up to x sub n, a discrete number of things. Okay, oops. And then we would divide that by n, however many there were. And that's our old-fashioned way to find average, okay? But what if we want to find the average value of a function? And remember, a function does not have a discrete number of points that we can calculate each value, because remember, there's infinite amount of points that make up a function, okay? So we're going to define the average value. So we will define the average value of a function like this, okay? So we're going to say f average equals 1 over b minus a times the integral, times the integral from a to b of f of x dx. So what we're going to do is we're going to integrate the function, okay, and then divide it by that distance traveled from a to b, okay? And that's how we'll find our average value of our function, okay? So this is another application of integration. So if I asked you to, find the average let's see here, value of f of x equals x squared on 0 to 2, the interval 0 to 2, okay? So what we would do is we would just say, well, f average is equal to 1 over 2 minus 0, because b minus a, right, times the integral from 0 to 2 of x squared dx. And that's it. And that would be our average value. So this would equal 1/2 times the value of x cubed over 3 from 0 to 2. And then so we get 1/2 times, what do we got here? That would be 8/3 minus 0. So we get, what was that, 8/6, which would be 4 over 3. And that would be our average value of our function. Okay, so it's pretty nice. It's pretty easy to work with. Okay, so now that we know how to find the average value of a function, what we're going to do is we're going to talk about the mean value theorem for integrals. So remember, we've done the mean value theorem already, but that was for derivatives. So now we're going to do the MVT for integrals. Okay, so it says if f of x is continuous, and by this point, I think most of you have realized that almost all of the things that we work with start off with continuous on continuity. So we have to basically say if the function is continuous. So it's a big part of calculus and mathematics, it's continuity. So if f of x is continuous on AB, then there exists a number C. I'll write out number. That is a element of AB such that, and then we have, we have the integral from A to B of f of x dx equals b minus a times f of c, okay? But if you think about this, this is the same as saying, if I divided both sides by b minus a, this is the same as saying 1 over b minus a times the integral from a to b of f of x dx equals f of c, okay? So what that means is this side right here is that's just f average. So then we can say, that is to say, f of c equals f average, okay? So that's kind of the idea of the mean value theorem. So we're going to look at it, what this means geometrically, okay? So geometrically, what this is saying is that let's suppose you have some curve, right? So I'm just going to draw some curve like this. Okay, oops, maybe a little bit steeper than that. Say we have some curve like that, okay? And we're going to go from, let's call this A, and let's call this B where it ends, okay? And I guess I could do this. Let's call this, I don't know, let's call this C right here, okay? So what I'm going to do is I'm going to draw this line. So let's say it's, again, this isn't perfect. I'm going to start it at A, and I'm going to draw this line y equals f of c, okay? And then I'm going to shade this in, okay? So then let me extend this a little bit. So just so you guys know, this is supposed to stop right here. I'm not drawing it perfect. This is B right here, okay? So I'm going to draw this, and again, I'm doing the best I can with this. So what this is saying is that we can have y equals f of c. This is the line y equals f of c, and this is the function y equals f of x. Okay, so let me kind of get my bearings on this real quick. So what this is saying is, so here's the thing. We have this area here, right? We have this area here under this whole curve. We have this area under the curve like this, okay? So what the fundamental theorem, I'm sorry, not fundamental theorem of calculus, what the mean value theorem for integrals is saying is that we can find some height, okay? We can find some height that when we create this rectangle here, the area of this rectangle will be the same as the area under the curve of the red, okay, of the function y equals f of x. So that's what this is saying, okay? So let me kind of show it to you, okay? So let's do a similar problem. So let's say apply the MVT for integrals to f of x equals x squared on 0 to 2, okay? So when we apply the mean value theorem for integrals, that means that we need to find all the c that satisfy the MVT, okay? That is all the c such that f of c equals f average. So we need to find all the c such that f of c equals f average, okay? And we know that c has to be between or equal to a or b. Okay, so I'm just going to start off with this. I'm just going to say f of c equals f average, right? Because that's what the MVT tells us. Now, number one, we know this is continuous because it is x squared. So x squared is, f of x is continuous since polynomial, right? So we're good on that. So check, okay? And then we're going to say, well, f of c equals f average. So that means f of c equals, now it's going to be 1 over 2 minus 0 times the integral of x squared from 0 to 2. Now we've already done this, right? Of dx. So then f of c is equal to 1/2 times, and then we know that this is going to be x cubed over 3 from 0 to 2, and we know that this is worth 4/3. We already know that. So we know that f of c is worth 4/3. We know that. But now what would f of c be? Well, f of c would just be c squared, right? Because it's x squared, so we just plug c in and we get 4/3. Now we're going to square root both sides. So then we're going to end up with c is equal to plus or minus 2 over the square root of 3, okay? Or approximately, let me see if that's exact or approximate. So, well, I know it's approximate, actually, never mind. So this is approximately plus or minus 1.155. Now, we have to make sure that these two values of c are in between a and b. Well, because a and b goes from 0 to 2, that means that we have to throw out the negative 1.155, okay? So that means that c equals plus 2 over the square root of 3, or c equals 1.155 if we're rounding off, okay? So we only count the positive, okay? So what I'm going to do now is, this is just kind of showing you what this is saying, okay? So I'm going to sketch a little graph of it over here. So let's say that we're graphing x squared, and I'm only going to go from 0 to 2, right? So I'm just going to graph like a zoomed in version of, oops, that's kind of drastic. I'm going to graph from 0 to 2. Let's say that this is 2 right here, and we obviously know that's 0. So I'm going to graph this parabola, okay? And then I'm going to go up, oh, I don't know, here's 1, right? So then 1.155 would be right about there. Or I'm sorry, not 1. F of 1.55. Okay, so here's A, right? So this is my A, and this is my B, okay? So what they're saying is that if I shade in all of this right here, if I shade this in red, right? If I shade that in red, they're saying that I should be able to find a height, f of c, that when I draw a rectangle based on that, it will be the same area as the area under that curve, okay? So let's say here's 1, right? So here's 1. So then that means, let's go with c equals 1.155. So that's going to be like right here, if we approximate. So then we're going to go like right here. Okay. So then, oops, I should have drawn that in blue. I'm sorry about that. So then we have the area of this rectangle. Okay, so we're going to find, so that's what we're saying here. So we can sketch y equals x squared, and the rectangle whose area is the same as the area under the curve, okay? So if I wanted to, I could find the area of the rectangle, and that would be a base of, what is that, from 0 to 2? So that would be a base of 2 times, now the height would be 1.155 squared, right? Because it's f of c. So let's see what we get on our calculator. 1.155 squared times 2. So that would be, and then let's do second function. Hold on. So hold on real quick, you guys. Sorry about that. There was somebody making noise out there, and I didn't want them to keep doing it on the video. So, so let's see what we get. We do 1.155 squared, 1.155 squared times 2. And this is approximately 2.66805. Okay, so what they're saying is that the area under the curve, hold on real quick. the area under the curve should be about 2.66805. Now, if we go back and look way up here, remember this problem? We would have got an area of 8/3, but remember, we were finding the average value, so we divided it by 2. So, and remember where the mean value theorem of integral says, is it says that the area under the curve is the same as f of c times b minus a. Well, b minus a, if you really think about it, b minus a is the base of the rectangle, and f of c is the height, h, right? So this is really saying base times height, which is equal to area of a rectangle. So this is just us manipulating it to have f average is equal to f of c, but this is what it actually says right here, right? So when I come over here, I now know that the area of the rectangle is worth approximately 2.6680. And again, if I didn't use the approximation, what if I use the exact area? Okay, I would do 2 times 4/3 square rooted squared, right? So this would just be 2 times 4/3, which is 8/3, which is the exact area, right? That would be the exact value of the area under the curve, okay? So that's what this is saying, is that we'll always be able to find some C, right, in between A and B, where you can find that height, and based on that height, you'll be able to create a rectangle, and that rectangle will have the same area as the area under the curve. And again, that's, you may think that there's, no big deal for that, but again, that's geometrically what's actually happening, is you're saying that you can always create this rectangle, kind of like the mean value theorem for derivatives said that f of b, that they'll always be at some point, the slope of the secant line and the slope of the tangent line had to be the same at some point on the interval. So again, something that seems a little obvious, that's also the same for this, where we can build a rectangle of any height that we want, and it'll have the exact same area as the curve. And this is just showing you how to find that height. Okay. All right, you guys. So I just wanted to show you guys that one. So that should be that. And then I had one like word problem that we could work on. Okay, so let me write this down. It says, oops, wrong problem. Here we go. So this is an example of average value. Okay, and it says the elevation on a hiking path is given by, and then we have f of x equals 500 cosine of 0.2x plus 1,000. Okay, where x represents the number of miles from the trailhead. Okay. And F represents the elevation in feet. Okay. Find the average elevation along the first 10 miles of the trail. Okay, so you're on this hiking path, okay, and this function right here represents your height, right? Where it says F represents the elevation in feet, okay? And X represents the number of miles from the trailhead. So it's basically giving you a way to calculate your height that you're at any given time on this trail. However, we want to know if you travel the first 10 miles, what is your average elevation along those 10 miles? Okay, so not what's the highest you were, what's the lowest you were, but on average, what was your height? Okay, so the first thing we have to do is we're going to set up f of c equals, okay? Now we know that c is going to be f average, right? We know that f of c, I'm sorry, not c, but f of c equals f average. So that means that we're going to do 1 over 10 minus 0, because that's, b minus a, times the integral from 0 to 10. And then we just take the function 500 cosine of 0.2x plus 1000 dx, okay? All right, so let's integrate this. So we're going to do 1 over 10. Now the integral of sine, so this would be 500 times the integral of cosine is sine of 0.2x, right? Oh, hold on real quick. Let me do this real quick. Let me do a little u sub over here, because I forgot we just kind of learned u sub a little bit ago, so I want to make sure you guys are aware. So we have the integral from 0 to 10 of 500 cosine of 0.2x dx. I'm just going to do this one. I'll do the 1000 in my head, but this one I'll just show you guys the little u sub on this. So we have to say u is equal to 0.2. 0.2x, so then du is equal to 0.2 dx. Divide both sides by 0.2 by 0.2, right? So then that means we really now have the integral. I suppose I could write the 500 on the outside. 500 integral of cosine of u, and then this would be 0.2 du. We divide by 0.2, right? So we basically have to find out what 500 divided by 0.2 is. And that gives us 2,500, okay? So that means I'm going to come over here and I'm going to put that in here. So this is going to be 2,500 sine of 0.2x, right? Plus, and then we know that the integral of 1,000 is just 1,000 x, right? And then this is going to go from 0 to 10. Okay. Now, let's see here. This will be 1 over 10. Now I'm going to do f of b, which would be 2,500 times the sine of 2, right? Because 10 times 0.2 would just be 2, plus, what would that be, 10,000 now? And then if I plug 0 in, the sine of 0 is 0. So if you want, I can do minus 0 plus 0. That's the f of b minus the f of a. So then this will just become 1/10 times. Now let's do on our calculator. You know what? I'll just put it in my calculator straight up. So 2,500 times, let me make sure I'm in radians. 2,500 times the sine of 2 plus 10,000 times 1 divided by 10. Or I could have just divided by 10. Sorry about that. So we get approximately, let's round to 3 decimal places, 1227.324 feet. So your average elevation was approximately 1,227 feet, if you wanted to just round off to the nearest foot. Okay, is equal to 1227 feet if we round off, okay? And that was our average elevation over this first 10 miles, okay? 1,227 feet, okay? All right, you guys, so I just wanted to do a problem like that for you because I think there's one like this in the homework as well. But let me know if you have any questions. That's going to do it for this video. Again, it's kind of a nice section. We're not going to go too heavy into this, but I just wanted to cover it. All right, you guys, thanks for watching. Have a good one.